Once you make a chemical change, you cannot change the substance back. It is irreversible. Notice I underline new substance with new properties. It's a very important distinction between that and a physical change. On test, you should be able to be given a scenario where there's been some sort of change, and you should be able to say whether it is physical or chemical. I made a boo-boo on the next part, so that's why I crossed out physical and put chemical. When you have a chemical change, you know what has happened by a few indicators. For physical changes, you know that if it's still the same substance and you just change the state or change the shape, like tearing a piece of paper, it's still paper. You know there hasn't been any major changes done to its molecular level. However, there are indicators to show that if there's a chemical change, that there's been a change at the molecular level. One of them is a change in color. And I'm not talking about when you mix red Kool-Aid in with water and now you have red water. This is a change in color when there's been no pigment added. So when an apple or banana is turning brown, that's decomposition. That is a chemical change. If I mix two clear substances and I make something that is purple, that's a chemical change. If there has been a change in energy, which means you have heat that's being released, or you have light that is being released. So something where there was no heat or light before, you've created heat or light. That is a chemical change. Fireworks are a pretty awesome chemical change. You ignite flammable chemicals and they react to create certain colors. Anything that burns or explodes is a chemical change. They're the coolest chemical changes. So if you have any situation on a test where they're like such and such set on fire, then you know it's chemical change. I already know it's chemical change no matter what else they say because something is on fire. If something explodes in the lab, what kind of change occurred? Well, Ms. Thomas said that there is a chemical change when there's an explosion. I'm going to go with that. If there's a change in odor, and everybody remembers what odor is, right? If you you had two substances that didn't smell very odorous to begin with, and you mixed them together, and now you made some stink, that's chemical change. Formation of a gas or solid where there was none before. When you form a solid from two liquids, that's called a precipitate, kind of like precipitation, like snow. So if I mix vinegar and milk, I don't recommend it, it's gross. It curdles the milk, creates a solid where there was none before. So you now have a chunky solution, which is a chemical change. Raise your hand if you have not mixed baking soda and vinegar before in your entire life. You've never mixed baking soda and vinegar. You've had a sad childhood, first of all. There's baking soda and vinegar everywhere. Good news is we'll get to do it sometime. Yay. Baking soda and vinegar is a solid and a liquid, yes? Solid and liquid. Look up. This is page 21. When I mix that solid and liquid together, I create bubbles, which is a gas. If I'm making a gas where there was none before, that's a chemical change. Never made a volcano, come on. So let me tell you about something really cool. No, I'm not going to tell you because I might do it. I'm not going to tell you. It's something I did for my kids' preschool class, but it actually might work for us too. And y'all like it. I'll save it. If you have a chemical reaction when there's heat involved, and usually most chemical reactions are involving some sort of heat exchange, it is either exothermic or endothermic. So root words, exo. What do you think of when you see the word exo? What word do you associate that with? Say again? Exit, which means going out, right? So if you're exothermic, your heat is leaving, so you hold it and it feels warm. Think about a fire. You feel the heat from a fire, yes? That's an exothermic reaction. Endo, think of indoors. You're coming in. Heat is being absorbed, so it feels cold. There are chemical reactions that you'll mix together and you'll feel it being cold. And this is already on my webpage, so if you feel like you're missing something, you can always go back and look on that when we get on the computers. Examples of chemical reactions. Burning, we've already talked about. Baking. Think about baking a cake. You've mixed dry ingredients, you've mixed wet ingredients, you've added heat, and you now have cake. Can you take that cake and turn it back into batter? No. Nope, it's forever cake. Hooray, cake. When you bake something, it's a chemical change. Digestion. And let me put an asterisk next to this, because this is not just a chemical reaction. When you think of digestion, what part of the body are you thinking about? Your stomach. That's the most common saying. Hey, digestion occurs most in the stomach. Not exactly true, but that is our first place that we go to. That is true that there is a chemical reaction going on in our stomachs that breaks down food. Now, I'm going to get gross for just a second. Can you turn what comes out back into food? First of all, ew, but can you? Do you even want to try? It is forever changed. So it is a chemical reaction. When your body mixes its stomach chemicals with what you eat, it changes it into something the body can absorb, and then what's left is waste. You cannot turn that waste back into food. However, digestion includes more than just chemicals. When I'm eating food, what's the first thing I need to do? I put it in my mouth, what happens? You gotta chew it up, right? I mean, I'm sure you like Jello or something, but for the most part, if you're eating a pizza, you're gonna chew it, right? Am I changing that pizza from pizza at that point? Is it still pizza? It's gross slobbery pizza, but it's still pizza. I'm just doing like I would shred a piece of paper. I'm just tearing it into smaller pieces to make it easier to swallow and digest. So, that's part of the digestion. So digestion is both chemical and physical. Physically, we break it down by chewing it. Chemically, we digest it in our stomach and intestines. So that's why I put that little star right there, because digestion is a chemical reaction once it hits the stomach. But before that, it's just physical. Photosynthesis. Ooh, we remember that from 6th grade? Anybody remember the formula for photosynthesis? I take, you stretching or answering? No, okay. So you take, what gas do I need for photosynthesis? What plants need? We breathe it out. Carbon dioxide. And I'm not going to let my plants dry up. I'm going to give them what? Water. And what energy do plants use? Sunlight. All right, we've got 3 ingredients. Once those are all in the plant, a chemical reaction happens. It changes it into a gas we can use, which is what? What do we need? We need oxygen. And it creates a sugar that the plants use for energy, which is called what? Glucose, C6H12O6. Totally different than what we started with. So that's a chemical reaction. We can't see it going on, but it's what's happening. If I mix 2 liquids together to get a solid, it forms a precipitate. When I mix 2 substances together and a gas appears as bubbles, that's a chemical reaction. One more I want to put down here. This is a big one. Rust. It's old school. You can go outside and see some rust whenever you want. Rust is when the iron in metals reacts with oxygen in the air and water. There's oxygen and water too. Chemical reaction occurs, and you're left with rust. Rust is irreversible. If your bike or car gets rusty, you can scrape it off the best you can, but you can't reverse it. It's forever rusted. Somewhere on your page, depending on where you can fit it in, so somewhere either on page 20 or 21, when we're taking notes about chemical reactions. advanced level chemistry classes, you'll get into the nitty gritty of what exactly the bonds are that are being broken. I'm not gonna get into that detail with you. All you need to know is that at any point in time, you're given a scenario. Deontay, you just not writing today? Because I know you didn't get 100 in notebook quiz, so let's write something. Anytime you're given a scenario and there's been a bond broken, that's a chemical reaction. Usually when chemical bonds are broken on a major scale, you have fire or explosions. Those are the fun chemical reactions. After you've finished writing all that down, the next thing we're going to do is do a little bit more individual work on chemical and physical reactions, mostly chemical, because you guys seem to have physical reactions down pat pretty good. You know, melting, freezing, boiling, adding heat, releasing heat. But we're going to focus a little bit on that and really a bit on chemical reactions, doing some practice with that. Well, I'll make sure that I have those down pat with you before I move on to balancing chemical equations, because that gets a little, I'm going to say, not a lot mathy, but a little mathy. I want to make sure we get the science down first. So once you're done copying notes, when you go back on Google Classroom, there is a chemical and physical changes stations. And again, these are stations. I'm saving the hands-on stuff for when we don't have computers out. I mean, it's probably funny, but it just makes me nervous with all these chemicals and laptops out at the same time. So let's get the computer stuff done first, and then we can start doing the hands-on science when we get all that done, okay? Not be crazy, but I just see bad things happen when we've got all these mixtures going on and nice Chromebooks. Wait, I didn't add it yet, did I? Quiz it, quiz it, quiz it. Yes, sir.
I really can't keep doing my legs and my right arm a lot because yesterday me and my cousin and my brother was on our bike until people start chasing us. I got off my bike. So I pinched my arms and my knee and on my back.
Oh, yeah, I see it. Okay, so I won't make you do any heavy lifting.
Okay.
Alright. Oh, wait, no. All right, if you're already in the chemical and physical changes stations, exit out and go back to classwork, because I need to make sure you have a copy for each of you and you're not like messing with the main copy, you know what I mean? All right, 6. if you don't see the chemical and physical stations, should be this right here. Yeah, refresh. Cause I had to delete the original and put a new one up so that everybody had their own. Make sure you are not talking. This is individual work. Again, if you're not sure about the first two stations, do the other ones first. I have the videos and the links, and that might help you out, but I'm hoping that you can answer most of these without assistance. Don't forget, we're still taking donations for the schools, who are affected by Hurricane Florence. Did anybody have Miss TJ last year? Okay, yeah, Icy. She teaches at a school in Wilmington now. She moved down the coast this summer, and they're on their 4th week out of school because their school's so badly damaged and students still can't make their way home, let alone go to school. So, places like that really need donations, really need help. If you got anything, and cleaning supplies, class supplies, whatever you got, they will take it.